Peeps, really long time no see. Although for some of you, I didn't mind seeing you over the spring break. But anyway, I shall not name names. You know who you are. Today's podcast will cover your Algebra Nation workbook, page 117, problem square root 81. And if you have moves like this referee here on the EOC, you will definitely get a $3.99. No, not moves like this clown tripping all over himself and falling with the basketball. That would be a fail on the EOC. Moves like this guy will get you a $3.99. Nice, he's got swag. This guy, ratchet. I digress.
A greenhouse that specializes in growing roses is divided into sections. The number of plants in each section depends on the number of sprinklers in the section. Okay, that's fine. That makes sense. Water and more plants or something. In a section with sprinklers, there are 3x times x plus 5. All right, daffodil plants and x plus 6 to the second power, a couple of rose plants. So there are two types of plants. This represents the daffodils. Those are pretty yellow flowers, okay? And this, oops, there you go. And these are my roses. All right. Write a simplified expression representing the total number of daffodil and purple rose plants in a section with X sprinklers. So when I see the word total and I know they're asking us to add. So I'm going to have to add. Okay. So basically, I'm going to have to add this plus this in its simplest form. Okay. Before I do that, though, let's try to simplify that some more. So I have daffodils are 3x times x plus 5. Right? I could simplify that a little bit, though. 3x times x is 3x squared. 3x times positive 5 is positive 15x. Let's do the same with roses. Roses. It's x plus 6 squared, which is the same as x plus 6 times x plus 6, right? All right. So if I see this, I know it's the FOIL method. So let's try first outside. X times x is x squared. X times positive 6 is positive 6x. 6 times x is positive 6x again. And I have lastly 6 times 6 is positive 36. Oop, there you go. I'm going to simplify. These are like terms in the middle. X squared, 6x plus 6x is 12x plus 36. There you go. All right. So x squared plus 12x plus 36 and 3x squared plus 15x. I'm actually going to add those together. This plus this. All right? That's what I'm going to do. So I'm going to write that down here. Whoop. 3x squared plus 15x plus x squared plus 12x plus 36. All right. Since I'm adding, I don't have to worry about signs changing or anything like that, so that's why I could just write it straight across. Beautiful. Let's combine like terms. 3x squared plus x squared. So it's 4x. 3x squared plus 1x squared is 4x squared. 15x plus 12x. Well, that's positive 27x. Don't believe me? Try that in your handy-dandy calculator. You always get one on that EOC, all right? So don't hesitate to use it. 27x. Finally, I have that plus 36 all left over, all by itself. I'm just going to bring it down. These are no longer like terms. Oops, let me get this up. There are no more like terms because it's the same variable raised to the same power makes it a like term. These both have x's, but that has x squared, and this one doesn't have an x squared. This one doesn't have an x at all. So they're all unlike terms. That has to be my final answer. All right. If you have any questions,